Okay, so again, just for the sake of the recording, we are going to work on section 8.1. The objectives you can read there. We're going to figure out exact values for inverse sine, and that's just where we start. We will find inverses for all of the functions. Okay. We're going to use the calculator for ones that we don't have memorized. Honestly, you can use it for ones that you have memorized too if you want to be lazy. Okay, properties of one-to-one functions and its inverse function. Okay, recall from before that for every x in the domain, it'll be an inverse if they're equal. So if you take the inverse of the function and put it f of x into that, or if you take the function and put the inverse in, if you get x out, then it's an inverse function. You guys can go ahead and write that down if you need it. Do you recall what inverse functions are? You should have covered in algebra. Also, just so that we don't have people staring at us, if you can let me know if you're going to write something down versus if you're just going to read over it later, just let me know so we can keep moving the slides. Okay. The domain of a function is equal to the range of the inverse, and the range of the function is equal to the domain of the inverse. Okay, so that's how they're kind of related. Okay. The graph of f and the graph of f inverse are reflections of one another about the y equals x line. Okay. If you do not recall what inverse functions are, that's a great place to start. I kind of relearned about this. I did not remember it in the slightest because I've been teaching algebra for so long. Apparently, not only is there a vertical line test, but there is also a horizontal line test when you are considering inverses. So for the sine function, you can see that the horizontal line test, does it succeed or fail with the sine function?
It fails.
It fails. So how is it, if the horizontal line test fails, how is it that we're able to have inverse sine exist then? What do you think?
Wouldn't it be like the secant, the inverse of it? I mean, cosecant?
Right, so you are correct. That is in the sense that the secant is the reciprocal of sine. It's a little bit different, but I get where you're coming from. So for sine function to have the ability to have an inverse, what we have to do is restrict our parameters, okay? So we have to restrict our interval. So instead of looking at sine of x from all possible options, from negative infinity to infinity, we have to look at it only from negative pi over 2 to pi over 2 for the x, and then between -1 to 1 for the y. And if you look at that section, that piece that was pulled out, can you see how it can be easily inversed? Okay, so you have to look at that piece. You can't look at any other area. Okay. Now you can move that chunk. You're allowed to move the chunk, but for conventional purposes, we typically only look between negative pi over 2 and pi over 2 because it's such a repetitive function. We don't actually have to look anywhere else. We can just leave it at that simple area. So here's your first definition. You definitely want to write this slide down. Y equals sine inverse x means that x equals the sine of y. And then that shows you the domain and the range. Okay. All right. Go ahead and do the best that you can with drawing this. If not, if you're using the computer, which that's funny because we're all using some form of the computer, you can just take a snippet or a screenshot of this so you have it. Okay, this kind of goes along with your definition, gives you a little bit of a visual. Okay. All right. So objective 1, does anyone need me to go back to that, or are you okay? Good, okay. Objective 1 is find the exact value of an inverse sine function. So here we're going to look at find the exact value of the inverse sine, or you can also call it arc sine, of -1. So in order to do this, we let theta equal sine inverse -1. And then we have to tell ourselves that theta is an angle between negative pi over 2 and pi over 2, whose sine equals -1. So we kind of have this setup going on based on our definition. And this example takes 3 slides. So, all right. So they were nice enough to give you the table below. If we look at it, we're looking between negative pi over 2 and pi over 2. Well, what option there gives you a sine of -1? And if you can't tell me this answer, you're just not looking at the screen. Okay.
Negative pi over 2.
Yes. All right. Now, if you were asked for a sine or an inverse sine of an angle that we do not have memorized, or we don't typically have memorized, you can definitely use your calculator, and we're going to get to that in probably in an example. So therefore, the only angle theta in the interval between negative pi over 2 and pi over 2, whose sine is -1, is, and just for those of you who can't see that, that is negative pi over 2. Therefore, they give you that. Okay? Any questions on that? All right. This kind of should be a refresher for everybody, but we'll keep working on the assumption that it's new. All right. Example 2 says finding the exact value of a function again. So we're looking for the inverse sine of square root of 3 over 2. So before we go to the next slide, if you guys were to try and do that on your own, what angle has a sine equal to the square root of 3 over 2, and it falls between negative pi over 2 and pi over 2? What do you think that answer might be? do you guys think? In that range, when are you going to have an angle whose sine is equal to the square root of 3 over 2? You can look at a unit circle if you need to. You can look at a table. If you want, we can go backwards and look at the last table. So you're looking for the square root of 3 over 2.
Yeah, it's pi over 3.
Very good. Okay, so since pi over 3 falls within that interval, that's your answer. Now, let me ask you this. What if you find an inverse and it does not fall into that interval? What do you think that would mean?
Like out of range.
So if it falls out of range, do you think there's a step you can take? Can you think of anything we did last week that might help you decide if you would have an answer?
You can use like a coterminal, or like you could add 2 pi to it.
Right, so not necessarily the terminal, but I guess kind of in a way. So we're going to look and consider the reference angles, okay? So don't just right away assume that you don't have an answer. All right, so the next thing we're going to look at is using your calculator when you don't know the exact answer. So here it says find an approximate value of each of the following functions. So we're going to look at sine inverse of 1/3 and sine inverse of 1/4. Now 1/3 and 1/4, is that something that your mind right away knows what the sine would be? No, there's not an angle that immediately pops into your brain that says, oh, the answer is 1/3 or the answer is 1/4. Okay? Because the angle is to be measured in radians, the first thing you have to do is make sure that your calculator is set to radians. Okay? So do you remember how to set your calculator to radians? If you don't, just ask. It's pretty easy. Okay? So once we do that, what do you think you're going to do? I want you guys to give me the answer instead of the slide. So we're kind of building on what we did in chapter 7 now. All those random things we did in chapter 7, now they kind of are coming back and you're using them. So how do you think we can find the inverse of 1/3 using the calculator? Does anyone see it on your calculator where it might look like an inverse function?
Yes, like you press second and then sine, and then you get sine inverse.
Good. Okay, and as long as you have it in radians, you're gonna get out a decimal. What do you think that answer means? How do you think you can, if I decide on the exam that I don't want you to give me radians, that I don't want you to give me just what the calculator spits out, what if I say I want to know what degree that is? So how would you get me that answer? What would you do additionally?
I think you multiply the answer by 180 over pi.
Perfect. Okay, so if you do that, you should get about 19.47 degrees. So what was your answer then for the inverse of 1/3? What was your decimal?
Yeah, approximate 0.34.
I will let you know, I'm not sure about Pearson, but the textbook likes you to round to 2 places. I'm telling you that for my solutions, on the exam, I'm going to want you to round to 3. Okay? I just would like that extra little bit of exactness. Okay, so if we do the same thing with 1/4, what happens? What do we get? What do you get before I let the slide give you the answers? Okay, well, I'm going to assume everyone knows what they're doing since it's kind of quiet on the home front. Oh, that's a negative 1/4. That makes the answer a little different, doesn't it? What would you have to do in that case? All right, so apparently they're going to let you get away with that decimal. It must be okay. All right. You don't have to find the reference angle all the time. I would have found the reference angle. All right. And don't be surprised if on your next exam you have to do that. Okay, so objective number 3 is use properties of inverse functions to find the exact values of certain composite functions. You want to write this down, okay? This property 1, 2a, and 2b, that's basically your, this is how I do this. So write it down. Okay. Do you guys have any questions up to this point before we keep going? Just want to know if you have any questions. All right. Then if you do not have a question, using property 1, what do you think the answer would be for sine inverse of sine pi over 9? What's it going to be according to our definition of property?
It will equal pi over 9.
Yes, perfect. Okay. Because pi over 9 falls within the interval, then you can just use the property. All right. What if we had to find the exact value for sine inverse of negative 2.5? If you need to, go back to the property and look at it. If you want me to, I can scroll back. If not, hopefully you wrote it down. What do you think that solution is? does this solution fall within the parameters of the property? Does it fall between -1 and 1?
No.
No. So it does not exist. It is not defined in that situation. Okay? Right? So you guys should really have an easy time with the homework for this section, I would think. All right, so cosine is pretty similar, except obviously there's a different set of parameters. If we looked at the entirety of the cosine function, is it able to be an inverse? Does it pass the horizontal line test? No. So again, we have to look at a subset or a different interval. So in this situation with cosine, we're looking between 0 and pi for the x and -1 and 1 for the y. Okay. All right, definition number 2, write it down. Y equals cosine inverse x means x equals cosine of y, where -1 to 1 for the x and 0 to pi for the y. All right. Definitely try and draw this and/or take a photo of it. Okay. All right, so similar to what we did with sine, we're just basically going to repeat the same things for all the functions, which is why sometimes this can get a bit confusing or it can be a bit easy, I guess, if you get it the first time around. So we're going to look at for the exact value of the inverse cosine of 1/2. So between 0 and pi, when is the cosine of that angle equal to 1/2? Do you guys remember? If you don't, you can use your unit circle.
Wouldn't it be like pi over 6?
Close.
Well, it's pi over 2, I believe. Or no. Root 2, I don't know. Pi over 4. Yeah.
Pi over 3.
Oh, yeah, because it's.
Yep, cosine. Yeah. Good job. So you're looking at, you want to always ask yourself, what angle will get me this answer out? Okay? All right. So before we go on to the next example, which is probably just putting a cosine then into the calculator, if I were to guess, any questions up to this point? Okay. All right. So now they want us to find the exact value of the inverse cosine of negative radical 3 over 2. So the first question is this something that you can work with, or do we have to maybe change some things with it? Okay, so if it's something that's allowed, you can go ahead and put it in the calculator if you want. Otherwise, you can find your exact answer. You can also use the calculator to check. So what's that answer there?
5/6, right?
Yep, 5 pi over 6. It falls within, so it's allowed. If you guys need to draw this out every time, you certainly can. Like I said, you can use the calculator as well as a check. All right. Property number 2, write it down. I'm telling you, if you write these things down, I would get like maybe a stack of index cards or something and just write, section whatever and all the properties related to it. Because if you do that, you'll end up with something kind of like this, where it's a nice little cheat sheet for all of trig. And everything's just really simple to go through and find. All right, so the inverse cosine of cosine of x is equal to x, where x falls between 0 and pi. All right, the cosine of the inverse of x is equal to x as long as x is equal to -1 or 1. Right? Don't know why they used x for both those when they used a different variable up top for sine, but that's what they're deciding to do. Okay. We're going to use the calculator to look at finding the exact values for the inverse cosine of pi over 15. And then we also want to consider the inverse cosine of the cosine of -3 pi over 4. So somebody walk me through it. What do you think you have to do?
I know for A it would be pi over 15.
Mm-hmm. Yep. A falls within, so pi over 15 falls within the range, so that is allowed. What about -3 pi over 4? Does it fall within the range? Does it fall between 0 and pi?
Yes.
It's negative. The PowerPoint has it very.
Oh, no.
No. Okay. So because it's not in the interval of 0 to pi, then what? What do we have to do in order to make it work? What can you remember that we covered in chapter 7? Cosines are what kind of functions? Are they even or odd?
Even.
Even. So because they're even, you're allowed to say that the cosine of -3 pi over 4 is equal to the cosine of 3 pi over 4. Because 3 pi over 4 falls on the interval, now you have your solution of 3 pi over 4. Okay. Eventually, you guys are going to look at this stuff and just know it intuitively. Okay. What about the tangent? What about tangent functions? What do you know about it? tangent function would pass a line test?
Well, like the regular won't, but if we apply the same principle, we just take one segment, it will.
Yeah, so we're just going to look at one section of it, okay? So y equals the inverse tangent of x means that x equals the tangent of y, but you have to look at where your y is at. You're only going to consider one slice of the tangent function, okay? There you can see the inverse tangent drawn out compared to the tangent function itself. Okay. I imagine chapter 8 is going to get harder, but right now it looks like it's pretty nice. All right, example 9, finding the exact value of an inverse tangent function. So if we want to find the inverse tangent of negative radical 3 over 3, what do we do? What would that answer be? So you want to find the angle between negative pi over 2 and pi over 2, whose tangent equals negative radical 3 over 3. When do you think that happens? If you think back on the tangent function, what we learned in chapter 7, the tangent of what angle is going to give you negative radical 3 over 3?
Five pi over 6?
Yeah, you can go with it that way. The other way to write it is negative pi over 6. But 5 pi over 6 would be the what?
Oh, yeah. Wait, so, yeah, I understand that they're like basically the same angle, but would you have to put the negative in front of the 5 pi over 6 too? Because the cosine of 5 pi over 6 is already negative root 3 over 2.
Right. So then that's going to be a different answer, a different solution. So you wanted negative square root of 3 over 3. So, and why does it have to stay negative pi over 6? If we use the reference angle, what happens to our angle? Would it fall inside or outside of the interval?
Inside.
If we use the reference angle?
Oh, no.
Fall outside, right? So we want to
Yeah.
start with negative pi over 6. Good job. Great questions. Here's your property 3. It obviously goes with tangent. Make sure you write it down. I'm going to put up my teacher notes as well, but obviously, if you guys like the PowerPoints, we can go through them too. I think the textbook is good to use in addition with these PowerPoints. So definitely not count them out entirely. Okay. So we want to find the inverse function of f of x equals 2 sine x minus 1, and it lies between negative pi over 2 and pi over 2. Then after we find that, we want to look at the domain and range. Okay, so using your definitions, what do you think you're going to have to do? How do you go from a function to its inverse? Algebraically. You guys remember?
Wouldn't you swap the x's and the y's and then solve for y?
Right, we're not going to flop, because if we just flopped, then you would, no, you're good. Okay, so if that helps you, if flopping helps you, you can use that technique. I would have just solved it for the opposite variable. But okay, so if solving for y is a technique that you remember and you're good with, then yes, use your approach of flip-flopping the variable spots and rewrite and find y. I probably would have just solved for the opposite variable. Either way, I think you're going to end up with the same result. It's just kind of like what helps you out the most. So if we start out with y equals 2 sine x minus 1, we're going to switch out the x and the y, and then we'll solve for the new y. So they added 1 to both sides, then they're dividing by 2, and then they're taking the inverse sign. Okay, so to go from one to the other, there's all of your steps. And then so the inverse function is equal to sine inverse quantity x plus 1 all over 2. If that is the case, what do you think your domain will be? What do you think your domain is going to be for this function? Is there anything that x can't be for this function? No, right? All right. To find the range of f, use the fact that -1 has to be greater than or equal to sine of x, which is less than or equal to 1. Okay, so then they go through and they solve. So their range is -3 to 1. All right. The domain of an inverse function equals the range of the function, and the range of the inverse function equals the domain of the function. Okay, so you have to write those down. That's the approach you're going to take. So you have to know your range and your domain of the initial function in order for you to figure out the domain and the range of the inverse function, right? They just flip-flop. I guess that's our mathy term for the day, flip-flopping. Okay.
So the domain is basically where the graph crosses the y-axis, right? Or is it?
So domain is typically when the x's, the inputs, and then the range is typically the outputs. But then if you're looking from the inverse side of it, those get flip-flopped because of your definition of inverse.
Yeah, I'm more asking, like, if you were purely just looking at a graph and you didn't know what the function is, how would you find the domain?
If you were looking at just a function, at just the
Graph,
drawing of the function,
yeah.
yeah, you're going to look at the, so just to give an example, if we go back and look at, okay, so if you were looking at this function, if this is what you were given,
Mhm.
then yes, from left to right, whether you're looking at the blue line or the red line, left to right is your domain for those respective lines, and up and down is your range for those respective lines.
Okay.
Make sense?
Yeah.
Okay. All right, to finish this out, we're looking at example 7. So we're solving an equation involving inverse functions. So you will go through and solve and find your inverse, and then once you find your function, note that when you solve, you get x equals sine of pi over 4, so then you're able to just solve for an actual x variable. Okay, makes sense? All right, these will probably be the harder problems for you on the homework. All right. We still have half an hour, so do you guys have any questions? Because if not, we can move on to we can move on to 8.2. Give me 1 second because I want to take attendance really quickly. All right, if you guys don't have any questions, we're going to keep rolling. Maybe we'll get both of these in today. Okay, so we're looking at 8.2 now. The inverse trig functions, apparently, still. All right, so we're going to find the values of expressions involving inverses, sine, cosine, tangent functions. We're also going to define the inverse secant, cosecant, and cotangent functions. And then we're going to use a calculator to help us do that, all of those. And then we will also write trig expressions as algebraic expressions, right? So I see why this is different now. Okay, so we have the sine of the tangent inverse of 1/3. So we have to kind of go inside out, right? So the first question you have to ask yourself is, what theta between negative pi over 2 and pi over 2 gives me 1/3? Okay, so the next thing you have to think about is if we're looking for sine of theta, because tangent of theta is going to be greater than 0, it follows that the theta falls between 0 and pi over 2, so then theta has to be in the first quadrant, right? Okay, if you look at the signs of that one. All right, so in this case, we don't have the exact knowledge of when tangent of theta is equal to 1/3, but we do know that we can use our algebra trig skills, right, to get the rest of that triangle. So the side opposite is 1 and the side adjacent is 3. So that will give us a hypotenuse of the square root of 10, which means that if we find the tangent inverse of 1/3 and then take the sine of that, we would end up with the square root of 10 over 10. Okay? Any questions on that? All right. All right, so everything really that we did in chapter 7 is all coming back around. This is exactly why I want to test on chapter 7, and then you can test on chapter 8. So then that way you're not getting things confused. All right, now we're going to look at the example of cosine equals to the sine inverse of -1/2. So this is what we have to think about first. We're going to let theta equal sine inverse of -1/2. So then that means that the sine of theta is equal to -1/2. So where between negative pi over 2 and pi over 2, you got to think about where you're looking at there. And then you also have to realize that you're looking for the cosine of theta. So because we have sine theta is less than 0, and we know that why, because it's equal to a negative number there, it follows that you're looking between negative pi over 2 and 0. So you're looking at quadrant 4. All right? You have to do this every time or you just won't know where in the unit circle you're looking at. So you draw your triangle. Here's your √3 and your -1. If you figure out your missing value, you're going to end up with a 2. So if you plug everything in, you end up with cosine of theta equals the square root of 3 over 2. Any questions on that? No? Okay. I think for the most part, if you guys do your homeworks in this for 8.1 and 8.2, then you will be good to go on, you'll definitely know what parts you need to explain versus what parts you're good with. All right. Now we're going to look at the tangent of the cosine inverse of -1/3. All right. So again, they break it down, and now we're looking at quadrant 2. All right. So honestly, what this has shown me is if you can break it down and figure out what quadrant you're in, if you can draw that out, if you draw these diagrams, I quite honestly might give you bonus points on each problem. If you end up drawing your diagrams on the exam, it's the same thing I told you for exam 1. If you draw out your diagrams, you're probably going to get bonus. If you get in the habit of drawing your diagrams, you will do much better in this course You'll do much better in physics. You'll do much better in calculus. Get into the habit of drawing your diagrams. All right. Again, we're just looking at our triangle algebra here. And, you basically do what we were doing in chapter 7. I'm really confused as to why this is a whole new chapter. All right. I would go ahead and write this definition down. If you don't want to write it down, like I said, I guess you can take a picture of it. If we have y equal to the inverse of secant, then that means that x is equal to the secant of y. But we have to remember that we're only considering positive x's greater than 1. And that y falls between 0 and pi. Notice that y cannot equal pi over 2. Why can pi over 2 not be an option for y? What do you remember happens in the graph at pi over 2? If it's a secant graph, you remember what happens there?
There's like an asymptote in that area.
Very good. Yep, there's an asymptote there. If y equals the cosecant of -1, or I'm sorry, wow, getting tired right now. The inverse cosecant of x, then x equals the cosecant of y. Again, you're looking at positive x values greater than or equal to 1. Your range is between negative pi over 2 and pi over 2, and y cannot equal 0. All right. And then you also have your definition for cotangent. If y equals the inverse cotangent of x, then x equals the cotangent of y. X is between negative infinity and infinity, and y ranges between 0 and pi. All right. If we want to find the inverse of the cosecant of 2, then you have to ask yourself what angle between negative pi over 2 and pi over 2 is equal to 2, or you could consider whose sine is equal to 1/2. Why can we do that? Why is that allowed? If you didn't want to work, oh, so sorry. If you didn't want to work with cosecant, why could you also consider sine equals to -1/2? Why is that allowed?
Because cosecant is the inverse of sine.
Yep.
In sense. Not the inverse, but more like the reciprocal.
There you go, the reciprocal. Very good. So the only theta in the interval between negative pi over 2 and pi over 2, whose cosecant is 2 or whose sine is 1/2, is pi over 6. Okay. Again, you can use your calculator. If you really want to use a calculator to figure this stuff out, you can. I do caution you though, because you're going to end up with a lot of decimals. So you're going to have to verify this every time with yourself if you're going to go through with the calculator. Because if the program wants exact values, it's not going to take decimal answers. All right. So this says, use a calculator to approximate each expression in radians in 2 decimal places. So obviously, if this was the problem on Pearson, then you can give them decimals. All right, so let's take a look at it. Again, make sure your calculator is in what? What mode does your calculator have to be in?
Radians.
Radians.
Radians, good job. All right, if we're looking for the inverse secant, how are you going to do that on the calculator? And for purposes, let's say that you don't have a fancy calculator that has secant, cosecant, and cotangent. Let's say you have to have a regular one. How would you do it on a regular calculator? What would secant inverse? How would you do that on the calculator?
You first have to take like the reciprocal of the number inside the function.
Right, so you could either do the reciprocal, which for this one would be 1/8, and you can use cosine, or you can do 1 over cosine, 1 over the inverse cosine, and still keep it as 8. Either way, either approach should get you the correct answer. And if you wanted to try it, then you can also you can type it in both ways and see what happens. Interesting. All right, to get an answer, what did you guys get?
I got 80. The first one I got 82.819, so 82.82. Oh wait, hold on.
Oh,
No.
you found it in
Yep.
degree,
Yep, I am.
but you got the correct answer, just so you know.
Yeah, it would be 1.44 degree radians.
Good.
1.45 if you're rounding.
All right, so they use the same approach. Let me tell you that if you do try to do it in the calculator, you have to use this method for some odd reason. If you're using the TI-84 plus or, lower than that, it gives you an error even when you do it correctly. So you have to use the approach that Yadel suggested and use the reciprocal. If you don't do it that way, I haven't been able to get it to not yell at me. So good approach, solid. All right, so let's go back so that I'm not giving answers out, but you guys are finding them. So this one would be cosecant. So we're going to do what? What are we going to use?
Basically the same thing, but with sine. So it's going to be -1/2.
Yep.
And that's going to be -0.52.
Perfect. All right. And just for the sake of time, we'll go ahead and look at the other two. The inverse cotangent of 1/5, you want to use the same approach, but with tangent. I guess they chose to use cosine. Let me see if we can get the answer for tangent as well, though. It gives you the same thing. So either approach you could use. And again, for here, all right. Last one. Writing a trigonometric expression as an algebraic expression. Okay. Definitely pay attention to this example. Okay. So write cosine of cotangent inverse of u as an expression containing u. So if we let theta equal the inverse cotangent of u, so that cotangent theta equals u from negative pi over 2 to pi over 2, and u is from negative infinity to infinity, this would mean that the cosecant would be positive. And then if you follow through with their logic here, you get cosine theta equals cosine theta times sine theta over sine theta equals the cotangent theta over cosecant theta. So then they made it cotangent theta over the radical 1 plus cotangent squared theta. And then they substituted in their u's. So definitely gonna be memorizing or using some of your identities. Okay. Any questions on 8.1 or 8.2? No? Okay.